Welcome to this explainer. When you look out your window, the world probably looks, well, pretty peaceful, right? A mountain just sits there, a valley lies below it. It feels like they've literally always been exactly like that. But what if I told you that the seemingly static landscape outside is actually the result of a massive ongoing geological battle? Seriously, let's dive into this because the ground we're standing on is anything but quiet. So, what exactly is this invisible million-year war shaping the ground beneath your feet? I want you to completely rethink how the Earth's surface was created. Throw out the idea of a slow, boring process where rocks just sit around doing nothing. We're talking about an epic, unrelenting clash of titanic forces. And honestly, the most incredible part? This very conflict is what ultimately creates the foundation that sustains all human life. Let me introduce you to the two main combatants in this war. In one corner, we have the Endogenic Forces. These are the land builders, the massive internal forces that violently push the Earth's crust upward. And in the opposing corner, we've got the Exogenic Forces. These are the land wearers, the external, atmospheric forces like water and wind that relentlessly tear that raised crust right back down. They are locked in an absolute perpetual struggle. Now, to really understand this, we gotta ground this epic conflict in the proper scientific vocabulary. We call these combatants geomorphic processes. Basically, these are the endogenic and exogenic forces causing physical stresses and chemical actions on Earth's materials. They literally bring about every single change in the configuration of the Earth's surface. The builders build it up, the wearers tear it down, and they're constantly seeking a balance that, frankly, they will absolutely never reach. Now, you might be wondering, okay, cool science, but why does this matter to me? Well, the crucial point is that we live directly on this incredibly sensitive battlefield. Everything we do, our survival, the agriculture that feeds us, our infrastructure, our entire future, it all relies entirely on this delicate geological balance. If we don't understand how these forces work, we risk destroying the very surface that sustains us. Section 1. The Builders, Endogenic Forces. Think about the sheer, unimaginable power required to actually build entire continents and mountain ranges. Where does that even come from? Well, it comes from intense geothermal energy deep within the Earth. The main sources are radioactivity, the friction from the Earth's rotation and its tides, and get this, the leftover primordial heat from the very origin of the planet itself. All of this energy creates an immense heat flow up in the lithosphere, pushing everything upward. All of that internal heat drives a process we call diastrophism, and it comes in two main flavors. First is orogeny, which is mountain building. This is when the crust is severely and violently deformed and folded to create those jagged peaks we all know. The second flavor is epeirogeny, which is continental building. This is a much broader, simpler uplifting or warping of massive parts of the crust. But both of these processes elevate the Earth's surface, effectively setting the stage for the counterattack. Section 2. The Sculptors, Exogenic Forces. Because as soon as those endogenic forces push the land up, nature steps right in to ruthlessly strip it back down. And the generals leading this counterattack? The sun and gravity. The sun provides the ultimate energy that drives our climate and atmosphere, while gravity is that constant directional force pulling everything downwards. Together, they power a massive suite of destructive processes that we collectively call denudation. We can actually break denudation down into three distinct processes that wear the Earth's surface down over time. First, we have weathering, which is the breakdown of rock right where it sits. Then we have mass movements, where gravity transfers that broken material downslope. And finally, erosion and transportation, where mobile agents carry the debris away. Let's look at each of these closely to see how environmental stresses literally fatigue solid rock over millions of years. Okay, let's start with weathering. The absolutely crucial thing to grasp here is that weathering happens on-site or in situ. There's little to no actual transportation happening just yet. It's simply the slow, localized fatigue of rocks through various attacks. This could be chemical, like acids dissolving rock, physical, like freezing water expanding in cracks, or even biological, like plant roots wedging stones apart, or earthworms burrowing through the soil. A super fascinating example of this physical weathering is a process called exfoliation. Kind of imagine an onion peeling. Under severe temperature stress, like the intense heat of the day, followed by freezing cold nights, the outer layers of a rock expand and contract until they literally flake off in curved sheets. This leaves behind these incredible, smooth, rounded domes out in the landscape. It's a really slow process, but it severely damages the rock's structural integrity. And once weathering has weakened that rock, gravity takes full advantage. This turns slow, quiet decay into sudden, violent mass movements like landslides, slumps, or rockfalls. But gravity usually needs a trigger, right? This could be heavy rainfall saturating and lubricating a slope, an earthquake shaking things loose, or, very often, us humans removing natural vegetation or cutting away the base of a slope to build a road. Let's apply this for a second. Ask yourself this real-world geographic question. Why do landslides and debris avalanches happen so incredibly frequently in the Himalayas compared to other mountain ranges? It's a perfect case study of these exact forces in action. To answer that, we can contrast the Himalayas with the Western Ghats. Think about the Himalayas for a second. They are tectonically very active, literally still being pushed up by endogenic forces. And they're made of relatively weak, unconsolidated sedimentary rocks on incredibly steep slopes. It's a complete recipe for disaster. Now contrast that with the Western Ghats, which are tectonically stable with very hard rock. But because they have extremely steep cliffs and receive massive, heavy rain that causes pronounced mechanical weathering, they still suffer from sudden, direct rock falls. Same war, different weapons, different results. So after weathering breaks the rock and mass movements pull it down, we finally get to erosion. Think of erosion as nature's mobile cleanup crew, entirely powered by kinetic energy. Geomorphic agents like howling winds, rushing rivers, crashing waves, and massive creeping glaciers acquire this weathered debris. They transport it across the landscape until they finally lose their kinetic energy, depositing all that material into lower basins and depressions. Section 3, the beautiful byproduct soil. You see, all that destroyed, weathered, and eroded debris doesn't just magically disappear. It accumulates and forms what we call the weathering mantle. And here is the ultimate plot twist of our explainer today. All this violent destruction and erosion is actually a deeply generative process. It is literally laying the groundwork for pedogenesis, which is just the fancy scientific term for soil formation. Let's walk through how this builds chronologically. How does barren, lifeless rock dust turn into a complex, sponge-like medium that actually grows our food? Well, first, that weathering mantle forms. Next, simple pioneer organisms like mosses and lichens colonize the bare rock. When they die, their remains accumulate as organic humus. This enriched layer allows minor grasses to take root, which eventually gives way to bushes and trees. Finally, after thousands of years, a rich, mature soil is born. But as you probably know, not all soils are created equal. There are 5 interdependent, basic factors that dictate exactly what type of soil will emerge from this process. We have the parent material, which is the original rock, the topography, or the slope of the land, the climate, the biological activity, and, of course, time. They all act in union like a giant puzzle. Now, of those 5 factors, climate plays a massively decisive, active role. Just look at the variations across the globe. High precipitation drives intense chemical and biological activity, but in wet equatorial regions, heavy rain literally washes away silica in a process called desilication. Conversely, in dry climates, intense heat evaporates water right out of the ground, leaving behind tough, salty crusts called hardpans. And what about the frozen tundra? Well, the cold completely stops chemical decay there, leaving mostly just mechanically broken rocks. And we absolutely can't forget the living creatures in all this. Let's zoom into the microscopic level for a second. Living organisms are the final, absolutely crucial ingredient in turning lifeless minerals into a dynamic ecosystem. Bacteria are working right now to pull nitrogen from the air to feed plants. Dead vegetation provides the necessary humus, and larger animals, right down to simple earthworms, are constantly mechanically reworking the soil up and down, completely altering its chemistry and texture. Which brings us to the human element. And we really have to face this stark reality. Humans have caused extensive damage to the environment through the overuse of resources. We are mining, farming, and building at a pace that the Earth simply cannot match. We're rapidly diminishing and destroying the very soil that took thousands of years of that epic geological war to build. But if we understand these processes, we can absolutely take precautions to minimize the damage and preserve it for posterity. So I want to leave you with this final thought. Next time you step outside, remember that you aren't just walking on dirt. You are standing on the beautiful, delicate byproduct of a million-year war between the massive forces deep within the Earth and the sun and gravity from above. So how will you protect the delicate, ancient soils that you stand on today? Thank you so much for joining me for this explainer, and keep looking closely at the world around you.